morning, friend. I am here again for my course, Aircraft Systems. Today I am in lecture number 15 and my topic of the day is oxygen and anti-icing system of aircraft. As you know, my name is Dr. Dwivedhi, professor from Institute of Aeronautical Engineering, Hyderabad, India. Today, my topics of the day are revision of air conditioning system, which I have covered in my last class. Then aircraft oxygen system, types of oxygen system in aircraft, typical continuous flow oxygen system, demand flow oxygen system, de-icing and anti-icing systems. These I will be covering in today's class. If I ask about the revision of my classes, I have started with module 1, that is the introduction to aircraft systems, and we have found in that there are 4 major aircraft systems, which are, first one is airframe system, then vehicle system, then avionics system, and last one was the mission system. Aircraft system or airframe system, both are same. The airframe system consists of the body part, that is the wing, then fuselage, then it is tailplane, vertical tail, canard and all. They are part of the airframe system. Then if you talk about the vehicle system, it consists of electrical system, pneumatic system, air conditioning system, hydraulic system, oxygen system, de-icing and de-icing system, and these all systems are part of the vehicle system. Then third one is avionics system. In avionics system, all the electronics equipments used for aircraft navigation, communication and their flight management system, the computers which are used for the operation of the aircraft is called the flight management system. So in avionics system, we have seen that how the communication of aircraft is taking place, how the pilots and the ATC and other person who all are away from the aircraft, they are contacting to each other. When we talk about the navigation, this navigation means giving the direction to the aircraft to reach to its destination. And these all things are operated by the help of the inertial system or the GPS system to navigate. So we have the gyro system, accelerometer and all the things, and in this way we are getting the inertial system, and GPS systems are used with the help of the satellite system. Now in my last class and in the mission system, we have seen that how the military aircrafts are performing their mission for a different type of scenario, different types of conditions like flood relief, firefighting, war, or any mission on board ship, anti-submarine warfare, reconnaissance, surveillance. These all are the few missions by which the aircrafts are performing. But this most of the in Corona period, this vaccination supply of vaccination and their necessary equipments like oxygen and other oxygen cylinder, other materials we have seen that aircrafts are taking. These all are called the mission system. For the mission system, we need some separate type of equipments. These equipments can be modified as per the required condition. And for a particular mission, only aircraft will be taking all the mission at a time. Aircraft is not supposed to undertake. So in my last class, I have discussed about the air conditioning system. So I will start with the air conditioning, and here we can see here this revision that air is entering from here. It is ambient air. This air is passing and entering in this. From here it goes to the, it is called the ram air, means it is slightly pressurized from the atmosphere. It is not the high pressurized, but it is much more pressure than the ambient air. So this little high pressure here, it is entering into the, it is trapped and it is entering to the heat exchanger. In this heat exchanger, and then it goes from air from here to this direction, and it is entering to the main engine. From main engine it goes to the main compressor. From this, at the final stages where the pressure is sufficient to take the air from the engine, and we see that this air is entering from here, and it is high pressure and high temperature. Both it is entering, and some 10 to 15% of this air is entering for the air conditioning, and remaining 80 to 85% to 90% it is entering to the combustion chamber, and here fuel is injected. This injection of the fuel is burning, and this combustion chamber is giving high pressure, very high pressure and high temperature gases to the turbine, and in turbine it is expansion is taking place, and here power is generated. This power is used to rotate the compressor for the engine. Now if you see the air conditioning system, from here it goes to the, in this direction, and a high pressure and high temperature gases which are not as high as the combustion chamber but a little higher, means it is 4 to 5 bar, and as per that the temperature is compressed air is entering here, and it is going in opposite direction. You can see that flow is from this direction, air it is going in this direction, but it is going in opposite direction, so that a better cooling is obtained by the gases. So it is little cooled, and this high pressure and little cooled is entering into the cooling turbine, and this turbine is rotated, and here expansion is taking place, and this gas which is entering here, it becomes much cooler, and it will go to the required places like air to cabin, air to electronics equipments. For all other purposes, this cool air is sent. And here this turbine is rotating the fan, and this fan will act as an exhaust, and it will make sure that this circulation is taking place in a very smooth way. So the power which is generated by this turbine is used to rotate this fan, so the efficiency of the system is increased. So this is a very basic air conditioning system used in the aircraft. The same processes are explained here. 1 to 2 here, this you can see, this 1 to 2 is ram pressurization. Ram pressurization. 2 to 3 is main compressor pressurization. Main compressor pressurization. Then here 3 to 4 is the heat exchanger. Heat exchanger. And then 4 to 5 is cooling in turbine. This is the cooling in turbine. Okay, so this is the process of the air conditioning, and in this way here we get the sufficient cooled air which is used for the aircraft cooling and pressurization for different purposes. Further, we have seen that these systems I have shown here with the help of the sketches. So you can see here that we have the air conditioning system. Here it is the engine, and here is the ram air is entering. From here this ram air is entering. This is, here it is called the, and it is, some part is, it is ambient, not ram. This is the ambient air. Ambient air. This ambient air entering in the engine, and from here a little pressurization, and this is the ram air here. Ram air, and this is the Here pressurized air main, after the main compressor it is, and here is a shut off valve. So we can open or close, and both are reaching to the primary heat exchanger as I have shown there. From here the high pressure and high temperature, and here all are, it is somewhat temperature is reduced here, some cooling is taking place, and this high pressure and high temperature is entering into another compressor, and here further pressure is increased, and this pressure again will go and it will be cooled to the ram air, and from there it will enter to the turbine, and here in this turbine pressure and temperature is reduced, and in this compressor pressure and temperature is increased. So this low temperature and low pressure air is entering to the water separator and the different filters, and then they are reaching to the mixer unit. In the mixer unit we can mix the hot air and the cold air, and it will be controlled as per the requirement of the aircraft. So this is a system which we can see that it is working in this way, and this is a simple air conditioning system of the aircraft which we normally used in day-to-day a simple aircraft. Further I am going for the vapor compression system. Till now I have discussed about the air compression, but if you see our household item, we use in fridges and all, we use in air conditioning of the home, we are using the vapor to, it is liquid refrigerant and it is used. So I will start with the compressor here. So we need a compressor, and this purpose of the compressor is to increase the pressure and increase the temperature of the gases. Then it is entering to the condenser, where this high pressure and high temperature, it changes to the vapor here, vapor to liquid here. And this high pressure and high temperature liquid are entering to the expansion valve. It is called the thermal expansion valve. Here this high pressure will reduce to the low pressure, and this will enter to the evaporator, where the evaporation will take place and the full temperature will lose here, and heat will be extracted from this area, and here a low pressure and the low temperature air is again entering into the compressor. So in this way the cycle is completed. In between we use a hot gas valve. If you want that here it is very much cool or the ice is formed very heavily, we have to remove this ice. It is called defrosting. So this defrosting can be done by opening this valve. If you open this valve, this air from here, it is cut and it will enter from here. It is hot air and this will enter here. So this system will be bypassed. Okay, this will not work, and only directly. So in this area it will be heated and the frosting can be removed. So that is the purpose of this. These are components. Now if I go one by one, the compressor has got the two main function. So pull low pressure vapor from the evaporator. So just you can see here that it is low pressure, it is sucking from here, and then the second is compress this vapor into a high temperature, high pressure gas. So this vapor is converted to the gas so that it may be condensed. So that is the purpose of this compressor. So here low pressure and the vapors are coming and from the evaporator, and this pulls, and then it is compress this vapor to into high temperature. So it is compressing and making high temperature and high pressure both. Okay, so gas, so that it may be condensed in the condenser. So here we have the condenser, and if you see we have here two types of the condensers are shown. Mostly this you can see this type of condenser you can see in the vehicles and all. So, and here also we have the air cooled, and this is the water cooled. In this water is used, so we cannot use in aircraft like water and all. So we use this air cooled, but in vehicle and all we use the water cooled. So we have to store some gallons of water in a tank so that this system should work. So here modine is a air cooled, this one is a modine, and this is the packels. So this is shown here. This is the packels. The name of this is given in this way. Now the condenser removes heat from the refrigerant by providing a medium at a lower temperature to which the heat may flow and be dissipated. So what the condenser does, it removes heat from the refrigerant by providing a medium. Means here water or anything we can use at a lower temperature to which the heat may flow and be dissipated. So a lower temperature, so heat will be dissipated in that zone. Superheated gas is converted into subcooled liquid. So in this gas which is superheated by the help of the compressor, it can be made as a subcooled liquid. So here two sources of this heat absorbed by the evaporator and heat added to the refrigerant during the compression. So these are the things which we have to see it. So these are the condenser, and it is shown here the purpose. So here the high pressure and high temperature, and here is from here gas, it makes the liquid subcooled. It is a subcooled liquid. Okay, that is the purpose of this condenser. Now a very important part is TXV, and it is called the thermal expansion valve. It is just like a pipe. It is shown here. Very capillary tubes are here, and I will show the in full detail also. And so here this expansion is taking place. Expansion of the high pressure here liquid will again convert to a gas. So thermal expansion valve and expansion device which throttles high pressure liquid to low pressure liquid expand during this process. Meters refrigerant into the evaporator based on temperature measured at the elevator outlet. So an expansion device which throttles high pressure liquid. Here just you can see high pressure liquid is here. Okay, just I am writing here this high pressure HP liquid. Okay, so this HP liquid, high pressure to low pressure liquid, here LP, it becomes LP liquid. Meters the refrigerant, and how much quantity of refrigerant is required? Quantity of refrigerant required. It measures, it calibrates, and it gives the same amount as much required by the system. And the temperature measures at the vapor outlet. As per the temperature and all, it will give that much amount of vapor, high liquid to low pressure liquid it is converting. Now onwards, I am going to give a new topic. Till now, I was discussing about the old topic, but as of now, I have to discuss about the new topic, and which is called the aircraft oxygen system. So, why we need oxygen? Why the aircrafts are required? To carry oxygen, or they have to make the oxygen and they have to fly? Because you know that as you go higher and higher, the density of the surrounding and the environment or the atmosphere is falling down, and the content of the oxygen in air is also tremendously falling down. As we go high altitude, we see that the amount of oxygen is limited. So the passenger, pilot, air crew, and all the necessary people who are on the aircraft, they need sufficient amount of oxygen. Otherwise, their systems may not work as it's supposed to work. To work, every human being or any animal which is traveling on air, they are habitual to be on the ground, and they are supposed to take the amount of air or amount of oxygen which they required. So the human body is dependent on oxygen, As the altitude increases, the consequent decreases in pressure reduces the amount of oxygen the human body can absorb when breathing. So, as you go up, the pressure reduces the amount of oxygen. Amount of oxygen also and pressure also reduces. The human body can absorb when breathing. So, breathing needs sufficient amount of pressure and sufficient amount of oxygen. To enable flight at high altitude, either the aircraft cabin has to be pressurized to replicate the pressure at a lower altitude, or the occupant of the aircraft have to supplement oxygen. At the cruising level commonly flown by commercial air transport aircraft, loss of pressurization can quickly lead to incapacitation. The higher the altitude, the lower the time of useful consciousness. So if you are not getting, a human being is not getting a sufficient amount of oxygen, they will become unconscious, and as you go higher altitude, that much consciousness, unconscious time of this thing will increase. So to have a proper working of each and every one, aircraft has to be pressurized or some other means has to be given to cater for this situation. Now I am going to discuss about types of oxygen system in aircraft. And we have seen that normally we have the two types of oxygen system in aircraft. That is the continuous flow system and demand flow system. So by name itself it is saying that continuous means it is continuing, it is flowing. And demand means as per the requirement, how much you want. As per that it will supply you the oxygen. So continuous flow system allows oxygen to exit the storage tank through a valve and passes it through a regulator, reducer attached to the top of the tank. The flow of high pressure oxygen passes through a section of regulator that reduces the pressure of the oxygen, which is then fed into the hose attached to a mask worn by the user. Once the valve is opened, the flow of oxygen is continuous even when the user is exhaling or when the mask is not in use. A preset flow of oxygen continues until the tank valve is closed. On some system, fine adjustment to the flow can be made with adjustable flow indicator that is installed in the hose in line to the mask. So in this continuous flow system, the oxygen is available all the time. Whether you are exhaling or you are inhaling, anytime your oxygen is available, and it is in the huge area. Like if you see in the passenger aircraft or when you are flying in Boeing, Airbus and some other aircrafts, you will see that you don't feel that there is a requirement. But if sometimes anyone feel that oxygen is feeling is less, or the person who is traveling is feeling some giddiness and lack of oxygen, then there is a system on top of, and a mask will fall down, and this you can put as this thing and you start breathing. So like this, so that is another system that is called the demand flow system, as and when required. So in a continuous flow, a continuous supply of oxygen is given with help of the valves, pressure control, pressure reducers, and all the things are there, and some indicators are also available. So by that, how much a limited amount of pressure and the quantity how much required is supplied as per the requirement. Here I am just showing the typical continuous flow oxygen system, and in this you can see that I will start from here. It is a charging point here. So on the ground we have to put one hose here, like this, one hose is there. Here is a truck. In this oxygen is filled. This oxygen is connected here, and with high pressure it is going from here. It is called the charging valve. This you can make on and off here. Then there is a filter. In oxygen, you may have some contamination, some other impurities. That impurities has to be filtered by the filter. From here, the air is entering to the check valve. This check valve is also called the non-return valve. Non-return valve. Another name is NRV. We just say normally in the short NRV. This check valve is provided. The function of this check valve is to give only one direction flow. It will go only in this direction. It will never go in this direction. It will not allow. So that is the purpose of the check valve. From check valve, it goes to the shut-off valve. Shut-off valve means you can make on and off from here. And if you make off, this will go to here in oxygen cylinder. It will be stored. And if you make another direction, it will go from here to here. So like this. Or if you make, it can go directly like this. So this valve, it is called the shut-off valve. You can close or open, and you can also put the direction either towards the cylinder or towards the system. Then again, a further filter, because here is the one more cylinder is there. So some impurities of this cylinder may come. So to prevent these impurities, and we need a filter. Filter has to be a very high quality, so that a minimum impurities or maximum impurities are trapped inside this cylinder. Then it goes to a pressure gauge. So in this, the pressure, how much pressure is required, that much pressure of the oxygen is maintained. And we have to make sure that this pressure should be sufficient as per the available human inside the aircraft. Then it goes to the pressure reducer, because we need some specific amount of pressure. So that much pressure only it will reduce. Suppose here we have the 3000 psi, but we need here 20 psi. So it will reduce here, and that much amount it will go. Then it will go to the pressure regulator. From pressure regulator, it regulates the pressure as per the requirement. And if it is excess, it will drain out. And if it is less, it will not allow to go less than that. So from here, if you see, here we have the pressure relief valve, and here a green blowout disc. So here pressure relief valve, if the pressure is more than the requirement, if suppose here we wanted 20 psi, and if it is that 21 or more, it will open and pressure will go from here. So now from here, pressure regulator, it goes to the system. Here we have the mask outlet. You might have seen in the aircraft, the air hostesses, how they are explaining how to wear the mask and how it will fall down. And as and when the pressure and the atmospheric, this level of the oxygen is falling down inside the cabin, automatically the mask will fall down, and it will be just hanging in front of you. Just you can hold it, and it will just pull 2 times like this, and your special oxygen will start. And here we have the calibrated orifice. This calibrated orifice will give as per the required of the particular person. So here 1, 2, 3, there are number of hundreds, 200, 300 as per the requirement. There are number of this mask and calibrated outputs are fitted. So this is called the continuous flow oxygen system. Most of the passenger aircraft, they have like this system, so that they can achieve, for each and everyone should get the sufficient amount of oxygen and sufficient of the pressure and sufficient of the temperature as per the requirement of the people on board aircraft. Now next one is the demand flow. So in this demand flow system, when oxygen is delivered only as the user inhales, in this it is not always, mostly whenever user want, that time it is mask is fixed here, and as and when he is breathing, he or she is breathing, it will go inside. So when the oxygen is delivered only as the user inhales or on demand, it is known as the demand flow system. During the hold and exhalation period of breathing, the oxygen supply is stopped. So whenever you are not taking inhalation, you are not doing, or you are putting your breathe outside, it will not work. But as and when you take inside, your oxygen valve will open, and the oxygen supply is stopped when you are exhaling. Thus, the duration of the oxygen supply is prolonged as none is wasted. So, in this 100% efficient and wastage of oxygen is not there. Demand flow systems are used most frequently by the crew on high performance and air transport category aircraft. So the pilots, they use normally this type of system, especially for fighter aircrafts and for the passenger aircrafts also nowadays they started using for the transport aircraft. So pilots, as and when they want, it will inhaling, exhaling. So during inhaling, oxygen will go. During inhaling, oxygen will not come. So just you can see here, I have shown here some diagram here. So here, if you see, this is a mask regulator, first observer station, crew oxygen cylinder located in forward cargo compartment, mask regulator, second observer station, mask storage box with mask regulator, captain station, and this is the first officer station. So this is the one pilot, this is another pilot, and these are the observers, and this is the cylinder located in the forward cargo, and this is the cylinder, and from this cylinder this system is coming. System shut off valve. So here is a valve. This valve, if you shut off, full oxygen will stop. So if you want to stop, full OT oxygen will stop. Full oxygen will stop if this valve is closed. Okay, so here we use this type of valve. Now I will go for the next topic. So I have given a brief idea about the anti-icing and the de-icing of the system. So we can see here that the oxygen is used for the survival, and it is very much essential, otherwise people will get unconscious and system will not work. Brain and other things all are dependent upon the oxygen. So we have to ensure that the system is working and oxygen is achieved by each and everyone. Now I will go that in the cold countries like Europe, Canada, Russia and other countries, Antarctica and all, a huge amount of ice is formed in atmosphere, and we see that these ice are not good for the aircraft and it will create lot of problem. You know that the wing and all the your fuselage, your horizontal tail and all, they are made very fine and very nice finish, very smooth finish, and if the ice is formed, the aerodynamic performance and the structural failure may occur. So in aircraft, we are not supposed to hold such type of thing in the aircraft. So anti-icing. So what is the meaning of anti-icing and the de-icing? So we have to first differentiate the anti-icing and the de-icing. We know a proverb that prevention is better than cure. So here we should try to prevent that icing should not form itself. So anti-icing means the prevention of ice buildup. Means we will make some arrangement that ice itself will not form. And de-icing means the removal of ice buildup. Means ice has formed, we have to remove the ice, and which is called the de-icing. Generally speaking, anti-ice device will be found on engine, while de-icing is found on flight surfaces. So in engine we use the anti-icing. So in engine it is not advisable to have any type of ice should go inside the engine. But in the wing and other things, if it is formed also, we will try to remove it. Pilot head keeps ice from forming, or pitot head keeps ice from forming, or in an indirect sense removes ice from the pitot tube. So pitot tube is one of the very important air data system from where air is taken to measure the altitude, speed, rate of climb indicator, and so many other equipments are operated by the help of the pitot tube. And so we should make sure that the ice should not form in the hole where it is very small hole is there, and if ice is formed, the system will not work properly and all the readings will be different. So anti-icing equipment is designed to prevent the formation of the ice. So we use the anti-icing system so that the formation of the ice is tremendously reduced, while de-icing equipment is designed to remove ice once it has formed. So I have told just now. So anti-icing means prevention. Ice should not form. And de-icing means if it is formed, we should try to remove it. Ice once it has formed. These systems protect the leading edge of the wing and tail surfaces, and pitot and static port openings, fuel tanks vents, stall warning devices, and wind seals and propeller blades. So these are the systems where we try to use this protect leading, the leading edge of the wing. Okay, so what is the leading edge of the wing? Just I will make this is the wing, this is the leading edge. And this is called the trailing edge. Okay, so leading edge and the trailing edge. So this we have to make sure that the pitot and static port opening, fuel tank vent, stall warning devices, wind seal and the propeller blades. These propeller blades are also very important because the thrust is generated by the propeller blade, and if the ice is formed, it will create the problem. Stall warning devices, there are some small holes there like these tubes. So if these tubes are blocked, then it is and fuel tank vents. The vents of the fuel tank, if it is blocked, the fuel supply will be restricted. So like this, we have to see that the ice and de-icing, we should follow the proper procedure. Here, thermal pneumatic anti-icing of the wing. So anti-icing, it means prevention. So how? By thermal and pneumatic anti-icing of wing. So this you can see here that we have here leading edge. These are the leading edge of the aircraft. Here, these are the leading edge. So this, we have here the system here, engine. From engine, a hot air is entering here. This goes to here with 3.5 psi switch. From here, it goes to the wing here. 350 Fahrenheit over temperature switch. If it is more than that, it will make the on. And here also 140 operation switch is here. Different types of overboard outlet. 212 Fahrenheit over temperature switches. Normally closed NC 41 psi regulator shut-off valve. Okay, so these are some switches. Thrust lever 60% switches. Overboard outlet, and here right hand load bus. So here it is shown, and this all leading edge, trailing edge, all the edges of the wing, they are the places where most of the time the ice is required to form, or it is forming. So here just you can see the more layout of the leading edge. This is shown here, the leading edge of the wing. It is here. So just you can see here, the leading edge diaphragm is here, inner skin is here, de-icing air duct. So here air is coming from this engine, hot air, and this hot air is injected here in the leading edge. Just you can see, and it is going from here. Exhaust is taking place. So in this way, air is going, and this, it is making this, your external surface hotter, and your ice is removed. So that is the purpose of this removal of this. Here the contour etched outer skin, this one the red color, inner skin this green color, and here we have the front spar, and here the exhaust gases will enter and they will leave from here. Now you can see the thermal electric anti-icing. the right angle of attack sensor here. All these sensors we have to protect them. Anti-icing is required. It is not de-icing. These all things should be protected so that the ice should not form in these equipments. Next, if you see here, right pitot probe here, then we have the right ice detector is here, then center pitot probe. So these are right and the center, and here T2 by T2 probe here, it is visible here. So pressure and temperature probes, and here if you see TAD probe, left ice detector and left pitot tube. So here the right pitot tube, and here we have the left pitot tube and left angle of attack sensor. So here the right angle of and both side of the aircraft angle of attack, so that you will get the average value and the results will not be so much. So these all things has to be anti-iced. Anti-icing should be done during design phase itself. During design phase of these systems, we have to make sure that this ice should not form. Otherwise, your aircraft will be in. You will not get the direction. You will not get how much altitude, how much velocity. All the parameters are measured by this. It will be very difficult for the pilots to handle such situation if ice is formed. Now, and next is the chemical anti-icing. So we have seen the thermo-electrical. It is a heat from the engine. It is a thermo, and here is the electrical systems by the heating elements we do. Next, we have the chemical anti-icing system. We spread some chemical component. So this chemical anti-icing is used in some aircraft to anti-icing the leading edge of the wing, stabilizer, wing shield and the propeller, the wind of the stabilizer and all. So this you can see here that here is the propeller, and this propeller is cylinder ring in spindle. We have to supply something, spray bar. Here, spray bar is here. Here we have the system. Here the tank is there. Some chemical is there. It is going to the high pressure switch, then filter, then solenoid valve, and this will go to the proportioning unit, and this will go to the leading edge of the aircraft. So like this, we can make it and we can use it for our purpose. So here I have taken this thing from some net also, and I have used this book, Moyer and the Seabridge, Aircraft Systems, Mechanical, Electrical and Avionics System, Professional Engineering Publishing Limited, London. And the second one is Design and Development of Aircraft System and Introduction. These two books I am following, and this you can see that these are very much essential books, and if you read these books, you will get a lot of essence, a lot of knowledge on aircraft systems, and it is very nice book. Try to read this book. And now I am in the end, and if any queries, you are welcome to ask. My email is ydwivedi@gmail.com. Please subscribe this channel and also like it. Any queries, you are welcome to ask in this email, and hope you have understood. And I will go with elaborate way of icing and de-icing in my next class. So be tuned. Please subscribe this channel and like if you feel it is good. Thank you very much for joining this class.
Like, share and subscribe. Hit the bell icon for more updates.